All right, let's keep rocking here. So we've seen that we have our web and data from the web that we're putting into Google Cloud Storage. That's what we're treating as our data lake now, even if we're not going through and doing a whole lot to set anything up there. And then let's make the next step in our flow here where we want to get our data and get it into our data warehouse. So let's make a new file, and let's call this one, let's call it ETL. I'm going to hit Command S on my Mac, and it's going to be ETL GCS to underscore BQ.py. So we're getting the data from Google Cloud Storage and putting it into BigQuery. All right. We've got some of the same imports we're going to need that we had last time. So let's just grab those imports. This time we're not going to need, oh, we do need that. We need that. Yeah, I think we'll need all those there. Let's add one more from Prefect GCP import GCP credentials. So this is another block, and this is the one that we did make earlier when we made our GCS bucket block, and we will use that here when we're writing out some data to BigQuery. All right, so first step here is let's also make our ETL flow, our main flow. And def ETL underscore GCS to BQ. Give it a doc string. This is our main ETL flow to load data into BigQuery, our data warehouse. And just like last time, we'll have a couple of hard-coded values here. We're just using yellow data and yellow cab data, and our year is 2021, and our month, we'll just do, again, just a single data file here to get you going. And let's call extract from GCS. Let's make that our first function. We're going to pass in the color, the year, and the month. And the result of that will be a path. So let's make our function extract from GCS. And we want the color, year, and the month. Color is going to be a string. Year obviously is an int, and month is an int. Lots of different ways we could do things here. So we're doing right now, and we are going to get back a pathlib object. Def. Okay. All right, let's download trip data from GCS. So you might ask, why didn't we just take care of this before? Well, what we're simulating here is we have this data in the data lake, and maybe anyone who we're working with might want it and can now take it, use it however they want. So we want to kind of separate those things and make sure that we have a clearer path for doing different operations. So we want the file, or f string here, our GCS path, let's call it that. GCS path is going to be an f string. Do a little interpolation here where we have color and underscore trip data. This is kind of like what we had before. I'm just going to grab the whole bit here to hopefully avoid typos. String, color. So this is the path we're looking for in Google Cloud Storage. Let's make sure that's what we have in that bucket. We've got Zoomcamp, so we have data, E, and then the color, and then yellow trip data. Data, color, So let's put data in front of that. Okay, and then our GCS block that we need to load in here, we'll call it GCS block, is going to be GCS bucket dot load, just like we had before. Again, my block name is zoom-gcs. Okay, and this time we're going to use the get directory method. And it's got a from path that is going to be set equal to our GCS path. And we need a local path for it to save information down to. So for that, let's call it locals fstring. We're going to go up a level from where we are right now and into data. And then that's all we need there. And our return value is just going to be a pathlib object with f string here pointing to that path data GCS path. Okay. And if we typed everything right, we will be good. Let's try running that. This is Python etl underscore GCS to bq.py. It's because it's in a folder. It's in the flows 02 underscore GCP folder. Flows 02 underscore flows plural. Okay. All right, so look through the file, but if we actually want to run something, we need if name double equals double underscore main. Then we're going to run etl GCS to BQ. All right, let's save that and run it. All right, get directory. I had an unexpected keyword argument, local. That needs to be local path. Okay. Again, you can check all this out in the Prefect GCP docs if you want to check anything out there. All right, so we got some data. It's right here. We have this in this case already, but if you were to delete it and then rerun it, you'd see the same thing. Okay, we'll do that in a moment because we will have more to do here. We're actually want to transform this data a little bit. So for our next step, let's do a very brief transform here. We're going to call a function named transform, and the result is going to be a data frame. So we'll call that variable df transform. This is our task. Let's add a task decorator here so we actually get some more info for both these. And maybe even worth doing adding some retries here, because that can be handy if something doesn't work, getting data from the web, especially a common case as we saw last time we talked. So now let's add another task, and this time we are going to pass transform a pathlib object, and it's going to return a pandas data frame. Data cleaning example here. Again, just not like a thorough data clean that we're doing, but what we're going to do is we're going to read in the pd.readParquet file. We're going to use the pandas top level function readParquet. Read in that file that's at that path, our data file, and we're just going to we know there's some missing data from some exploration we did before, so I am just going to say that there was a missing passenger count in the passenger count column. There's just no values in there. That's not optimal. So let's do isNA dot sum. All right, and then let's actually fill that passenger count, df passenger count column. Dot fill na. We'll fill it with zeros. So if there's missing data, there's no passengers. Missing data can be a big issue, and it's something to think about if you're doing data science type work. But in this case, we're just going to make the simplifying assumption that if there's missing data, it's because missing passenger data, it's because it should have been a 0, and someone just didn't fill it out. Say we have inside information. All right, so this is the post missing passenger count data here, isNA.sum, and let's return the data frame. Looks good. Let's run that, just do a check on it. What did we learn? 98,352 folks missing before, and then after we're seeing the same thing here. Missing passenger count. Filna of 0. Filna needs to, can we do that one in place? Yes, needs an in place equals true. Or else it doesn't actually alter the data there in pandas. We could also just have overwritten the column, but there we go. Post, now we have no missing passenger data. All right, so good thing we had that check there. All right, so for the last thing now, we're going to take this data, write it into BigQuery. So let's go ahead and make our function call is going to be write BQ, and we're going to pass in the data frame. So let's go ahead and start making that task. And again, this is going to be called write BQ. And it's got a parameter called DataFrame, which is a pd.dataframe object, pandas dataframe object, and we're not returning anything. So there's a lot of ways we could get our data into BigQuery. What we're going to use is we are just going to use the pandas toBigQuery function to do that. df.toGBQ is what it's called. And we need to give it a destination table and a project ID and credentials. And to get those credentials, we'll have to give it our Google Cloud Platform credentials. And we're also going to make a chunk size so that it will just write out 500,000 rows at a time, which is, we could do it all at once, but it's nice to do it in smaller batches. And if this table exists, we are going to append to it. So that is an important feature there. So again, you're going to see more about BigQuery, but let's just go over and get it set up right now. All right, so if you're in Google Cloud Storage here or wherever, in Google, you can go ahead and search for BigQuery or go down to the hamburger menu and pick up BigQuery. And you're going to click on Add Data, and you can choose the data source. We already have data in Google Cloud Storage, so super convenient. We can use the UI, click on Google Cloud Storage, and then select a file from the GCS bucket. So we can browse. We have our GCS buckets here. We have data. Great. Where's our Parquet file? Let's use that. And then file format is Parquet, that's correct. We have the project we want it to go into and a data set. If you don't have a data set, make a data set. My data set ID, letters, numbers, and underscores are allowed. I'm calling mine DE Zoomcamp. Do whatever you want with yours and create that data set. And then choose it, DE Zoomcamp. And then we have a table. I'm going to name my table rides because this is ride data. You can name it something else if you wanted. No partitioning, no advanced options, everything's fine there. Hit create table. So we have a little pop-up here that load job is created. It'll take maybe a minute to go get it all the way created. You can go to the job if we want, or it'll automatically stop for us. And if we expand our project here, we can see that we have our DE Zoomcamp and we have our rides table. Awesome. So if we click on rides there, we see that we should have all of our columns that we would expect. So it's nice that it makes that schema for us. And then we have some data in here already because we just kind of brought it all over. So let's just delete that. I'm going to click on query here in a new tab. And as you can see here, if you do a select star from your table, you do have that data in it. So we want to delete all of that. So I'm just going to copy paste a little SQL to do that. So BigQuery is super handy. Again, you'll be learning a lot more about it as you go here. I'm going to just point out now that it is a data warehouse where we have SQL data in a nice columnar data store that we can access and do some analytics processing with. Very nice for folks who want to go and see at a high level what's going on. Your data analysts, your analytics engineers will spend a lot of time in your data warehouse. So BigQuery is a great option for them. All right, so got rid of the rows there, and now again we're just kind of simulating how we're going to move this data in. So let's go back to our code here, and our destination table. Again, this is just a pandas method that we're using here to write out our data frame information right to this table. So my table is de zoomcamp.rides, and my project ID is this project ID that I have here, Prefect SBX Community ENG. That's again just my personal one. And then credentials. So this is often a kind of a muddier thing. We want to actually get some credentials so that we have access to go and write to this database, data warehouse. So how are we going to do this? Well, we already have our credential information for GCP loaded in via our work earlier in the blocks. So we've got this credentials block. So we can use that right here. So let's copy this, and we can hit tab, paste. So we already have the import up above in our file. So let's just do GCP credentials block equals GCP credentials block dot load. That's all we would need right there. Great. And then now we have it loaded right here for our argument for credentials. We can say GCP credentials block dot get credentials underscore from underscore service underscore account, and that's a method, and you can learn about that over in the docs for Prefect GCP. That's where you can check out that. So storage is here. We can see credentials. You can see how to get these credentials. It's pretty cool. And if you want info from pandas about how to kind of get this information, there's the pandas dataframe.to gbq. All right, so let's hit save here, and let's run this. So again, what's happening now is that we are pulling this data from Google Cloud Storage, and we are making a transform on it, and then we're writing it directly into BigQuery, and we're watching all the action happen as we go. So now if we go over to Google BigQuery and we click on query here, if we want to make a query, and just run that. We should see that we have data there. Yep, it's all there. And if we wanted to get a count on it, we can just do count of star from rides, get rid of that limit, and run that. That's our number, 1369765. Awesome. We've seen how we can use Google Cloud Platform and Prefect together, along with some nice Python code here, to move our data around and get a little bit of observability as we go. In the future, we'll see how to orchestrate these ETL flows so that we can really automate things and run things on a schedule and have them work in a more robust manner. Until then, have a good time.